Hi, and welcome to Allen High School's discussion of solutions. We're looking at solubility curves and calculations involving those solubility curves. Now, there's some words down here, but I'm going to jump in and work some for you. Here's an example of what might be asked. We're looking at the amount that would saturate. This particular example is looking at KClO3, so you want to make sure you capture the correct line there. So that's the KClO3 line at 40 degrees Celsius. Well, this chart gives us the amount that will saturate 100 grams. So the first thing you want to do is determine how many would saturate 100 grams. And we're at 40 degrees, so if I go from 40 degrees up to the line, so I'm going to start here, I'm going to go 40 degrees up to the line, we see that it's 15 grams. Now we recognize that you're estimating there, and that's going to be acceptable. All right, so that's how much would saturate 100 grams. Now notice that this said 550 milliliters. Well, since we're talking about water, we're going to make the assumption that 1 gram takes up 1 milliliter of volume. So you'll see that used quite a bit. If you see milliliters, just convert it directly to grams. Then we're going to set up a proportionality. So if we have 15 grams per 100 grams of water, that's going to equal X grams in 550 grams of water. And when you solve for X, you would get 82.5 grams. All we have to do is cross multiply there. So let's take a look at these next examples. I'm going to be a little selective in which ones I do, because I think you'll get the hang of this pretty quickly. So which of the following solutions? We're going to decide whether they're saturated, unsaturated, or supersaturated. So we have 40 grams. So let me use my arrow to track this. We have 40 grams of the substance at 80 degrees. So, 40 grams, and I'm going to go over to 80 degrees. So I'm right there, 40 grams at 80 degrees. So that's the point I'm looking at. Now, it's asking me what that is for a solution of KCl. Well, if it was KCl 40 grams, this is below the KCl line. So for KCl, this is actually unsaturated. Apostrophe D for saturated. All right, so what if I have 120 grams in 100 grams of water at 60 degrees? So I'm going to go up to 120 grams, and I'm going to go over to 60 degrees. So that would drop down, just make sure I'm at 60 degrees. So we're talking about this point right here on the curve, and it's asking us about KNO3. Notice that that point is above the KNO3 line, so we would say that is supersaturated. Above the line is supersaturated. Now, 80 grams of NaNO3, so I've got 80 grams dissolved at 10 degrees. So I'm just going to go over to 10 degrees. So this shows you the point that we're looking at right there. And we're talking about sodium nitrate. Well, that is right on the line for sodium nitrate. So that would be considered a saturated solution. Okay, so that's how we read the graph. Let's do some mathematics of these. Which of the salts is the least soluble at 10 degrees? So let's take a look. Let's follow up 10 degrees. That's this line right here. And you notice that Ki is the most soluble, and that KClO3 is the least, has the fewest grams per 100 grams of water. Which of the salts has the greatest solubility? Notice that it's the greatest increase in solubility as we go from 30 degrees to 60 degrees. So really what we're looking at is the one with the biggest slope. And you notice that KNO3 goes up the most drastically between 30 and 60. It's going from about 45 to 100 grams, or a change of about 55 grams. Whereas you'll notice that ammonium chloride, just to grab a random one, only goes from 40 to say 55. It was only 15 degrees. So that answer would be KNO3 because it has the biggest slope, and the biggest slope represents the greatest change. The next one, which of the salts is affected the least by the change? This is the one that's going to have the smallest slope overall, the smallest change. And if we notice, good old common NaCl is almost flatlined right there. Okay. Now, let's take a look at some examples. Now, this one may have a typo in yours, so look very carefully at mine. Hopefully we caught that. Notice that it says sodium nitrate here and sodium chlorate here. That chlorate I'm changing to a nitrate. I'm not sure what that is in your notes, so make sure that that's consistent. All right, so we have a saturated solution of sodium nitrate, contains 100 grams of solute and 100 mLs. How many has to be added to saturate? Okay, so I have 100 grams to saturate at 50 degrees Celsius. So if I go from 50 degrees up to sodium nitrate, notice that 115 grams are required to saturate 100 grams of water. Well, I already have 100 grams of sodium nitrate, of solute, in what's effectively 100 grams of water. So I would have to add 15 grams to get my total of 115. Got to read these very, very carefully. Now, this next one, I'm going to go down here, and basically this one actually includes 15. How many grams, I'm looking at potassium nitrate, would it take to saturate 300 grams of water? In other words, I'm at 50 degrees Celsius. I want to know how many grams of KNO3 will go into 300 grams of water. Well, my chart doesn't read for 300 grams of water. It reads for 100 grams of water. So what I do is I go to 50 degrees here, and let me make that visible there. I'm going to go to 50 degrees. I'm going to go up to KNO3, and I go over and I find that 80 grams will dissolve in 100 grams of water at 50 degrees Celsius. So I'm assuming linearity there as we increase solvent, which is a good assumption. If I solve for X, I get 240 grams of KNO3. Will dissolve in 300 grams. Hopefully you're seeing the logic there as well. And I hope you notice that that effectively answered the one above it. Okay, let's take a look at 12-17. These are getting trickier and trickier. So I have a saturated potassium nitrate at 50 degrees Celsius. Again, we're really looking at the same situation, and we just discovered that 80 grams of KNO3 is required to saturate 100 grams of water at 50 degrees Celsius. Now, this time, instead of changing the temperature, changing the amount of solvent, we're still looking at 100 grams, but we went down to 10 degrees Celsius. So at 10 degrees Celsius, so we go 10 degrees up to my potassium nitrate. Make sure you're reading the right salt. I get about 22 or 23 grams will stay saturated. So this is saturated and this is saturated, but what did the question ask? Read it carefully. It asked how much would precipitate out. So my precipitate is going to be the amount that started minus the amount that stays in a saturated solution, and that difference is 53 grams. So be careful whether they're asking you how much stays in the solution or how much will precipitate out of the solution. All right, let's take a look at this next one. I have a solution in 400 grams of water, and I've dissolved 40 grams of KClO3. And the question is, whoops, I forgot my L there, sorry. The question is it saturated? Would the solution be saturated at 20 degrees? Well, I can't read on this chart saturated for 400 grams. I have to translate this into a per 100 grams. So I would have to solve for X here. And I find that X is equal to 10 grams of KClO3. So I go over to 20 degrees Celsius. At 20 degrees Celsius, and I go up to 10 grams, I'm right here, right on the line. And in what I'm reading from what I looked at the cesium. See how you have to be so careful with that? My bad. Look at, I'm actually looking a little above the line. Do you notice I'm just a teeny bit above KClO3's line? So that would make this a super saturated solution. Okay, hopefully you're getting the hang of these. I just want to do a few more. We'll do as much as time allows us here. So let's go on to 1219. I've got a liter of water, and I want to produce a saturated solution at 50 degrees. Okay, well, first off, I can find a saturated solution at 100 grams and 50 degrees. So I'm going to go 50 grams. It's potassium chlorate. So at 50 degrees, 20 grams will saturate at 50 degrees Celsius. Now, the question, though, asked me about a liter of water. Remember what I said about density. 1 liter is the same thing as 1,000 milliliters, and we're going to assume that the density of water is close enough to 100 grams that we'll get the right, or 1 gram per milliliter that will get the right answer. Now, that's not really true at 50 degrees Celsius, but it's still very, very close. So we're going to make that assumption that our density is 1 gram per ml. And if we solve that, we would get 200 grams would be our X. That would equal X in the numerator there. Okay. I'm going to jump on to 21. I picked a few that I thought were the trickiest. Now we have, the question tells us we have 30 grams of KCl and 100 grams of water. Do you notice I just automatically converted that? At 45 degrees Celsius. The question is, how many grams of KCl are needed to make the solution saturated at 80 degrees? So this is what I have at 45 degrees. So now let's go to our 80 degree, and at 80 degrees for 100 grams, so this is 80 degrees Celsius. To saturate KCl here, I've got 80 up to here, it takes 50 grams. So I have 50 grams per 100 grams of water at 80 degrees, and I have 30 grams at 50 degrees. Now notice that it said how many additional grams do I have to add. So if I have 30 and I need 50, hopefully that you can do that math in your head, you would see we would need 20 additional grams to get to that saturation point at 80 degrees. Okay, let's jump down to 24. That's a tricky one. And Let's take a look at that from the graph. We have 100 grams, 160 grams of potassium nitrate added to 200 grams at 100 degrees Celsius. How much will dissolve and how much will stay on the bottom? Well, if I have 160 grams per 200 grams of water, that means I would have 80 grams in 100 grams of water. Okay, so would be what I would have. So let's take a look at 10 degrees Celsius. We want to see how much will go on the bottom. Now trace over, I've got 80 grams here. So if I follow 80 grams up to my 10 degrees, up to 80, excuse me, up to my potassium nitrate. So way, 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 way up here. Okay, and I'm off the scale here for no, that's sodium. I'm off the scale for potassium nitrate at 80 degrees. But it told me I had 80 grams, so I'm going to go down to 10 degrees and notice that at 10 degrees, only 20, at 10 degrees, only 20 will stay in. So if I went from 80 to 20 grams, all right, for this, if in 200 grams, I'd go from 160 down to 40, and that means my answer would be 120 grams would precipitate out. Okay, because 160 minus the 40, it would give me the 120. Okay, there's another couple on here, especially 26 is a tricky one, so if you're not getting these, I'll work that out, but our video is well over time. So until I see you on our next video, this is signing out. Man, I wish I'd just cut that off. I don't like how I did that.